Okay, this transformation that we're going to look at are reflections. Okay, if you remember, reflections are where we flip our shapes. Okay, let's zoom in here on our description. Okay, so for reflections, the figure that we have is flipped over a line. There we go. Now there is a formula for reflections. We haven't seen the formula yet, but I did want you to have access just in case you like memorizing formulas. You can memorize this. What ends up happening with reflections is we start with our ordered pair, and if you notice, my x stays the same, but my y becomes the opposite. So when we reflect over the x-axis, x stays the same, y becomes the opposite. If we look at the reflection over the y-axis, x becomes the opposite, and y stays the same. So whatever axis we reflect across, that ends up staying the same. The other ordered pair, or the other coordinate, becomes the opposite. You don't have to memorize the formula. I will still show you the process by hand, but the option is there. Let's look at example number 1. Reflect over the x-axis. So if I look at my shape, I have a triangle, and when we reflect, if I'm reflecting over the x-axis, that's right here. Okay, and I'll usually draw a little squiggly kind of line. So what I'm looking at is if I focus on A. If I look, I need to see how far is A from my axis. Well, my A is 1, 2, 3 away from my x-axis, so A prime will be 3 away from the x-axis the other direction. So if A is 3 up, A prime will be 3 down. B. B is 1 unit above my x-axis, so B prime would be 1 unit below. C is 2 units above my x-axis, so C prime will be 2 below. And if I write my ordered pairs, I'm going to get 2, -3 for A prime, 3, -1 for B prime, and 1, -2 for C prime. And if I just plotted or figured out my ordered pairs, if you look at your formulas, this does follow the formula. Okay, so what I want you to do for example 2 is we're going to scribble out this last part here, because it won't always be as easy as x-axis, y-axis, and this is a review, so I want to make sure that you see everything. So we're going to reflect the rectangle over the line x equals 1. So I want you to scribble that part out and then write the line x equals 1. Okay, so remembering how these lines are drawn, x equals 1 means that no matter what y is, x will be 1 on my line. So if y is 1, x is 1. If y is -1, x is 1. If y is 5, x is 1. So this line right here is my line x equals 1. That's my reflection line. So a reminder of how we handle this. I do the same type of thing as I did on the last problem. I'm looking to see how far these points are away from my line of reflection. So if I start with M, I need to see how far M is away from my pink line of reflection here. So I'm going to count. 1, 2, 3, 4, 5, 6. M is 6 units to the left. So my M prime will be 6 units to the right. 1, 2, 3, 4, 5, 6. Okay, A. A is 1, 2, 3 units to the left. So my A prime will be 3 units to the right. Now, I do notice that M and H are the same distance, but two apart. Same thing with A and T. So I should be able to do those easily because it's a rectangle. But still, T is 1, 2, 3 units to the left. So T prime is 3 units to the right. And then when we put our ordered pairs, A is 1, 2, 3, 4, -3. Oh, that was A. M is 6, -3. T prime is 4, -5. And H prime is 6, -5. Now if we look and see what happened, my y coordinates all stayed the same. Because this x equals 1 line is actually parallel to the y-axis, it does act the same on the y coordinate. The x coordinate doesn't follow this pattern though. Okay, the x coordinates don't follow this pattern. So I want you to make a note here that says only work when reflecting over the x-axis or y-axis. This does not work all the time, which is exactly why I don't push the formulas. I don't want you relying on the formula that's not going to work every time. Okay. So we notice my y coordinates are the same, just like if we were reflecting over the y-axis, but my x coordinates are a lot different. So just be careful. Always trust the pictures. So now if we look again at our shapes, let me move this over a little bit. Pre-image and image, are they congruent? Are they similar? If we look, do you see how my beginning and my pre-image and my image are actually the exact same shape? So that means they are congruent. Okay, corresponding angles. Now corresponding angles would actually be these two because it's the upper right and the upper right, but are they sorry, are they congruent? Okay, and actually I take that back. Our corresponding angles are still the A matches with the A prime, M matches with M prime, and they are still congruent. Sorry, I had a moment. I wanted to make sure I was giving you the right info. Corresponding sides. Okay, our side AT would correspond with this A prime T prime, so they are also congruent. And we know that because if we look here, this angle A is corresponding with this angle A, and they are still congruent. Remember, if the shape doesn't change, if it doesn't change the shape, things are congruent. And that's it.